Cut. Here we go. All right. Let's see what's going on here at the very back to the beginning. All right. It says the number is chosen from random from 1 to 25. Find the probability of selecting an odd number or a multiple of 5. What did you get? I just want the answer.
3/5.
Somebody said 3/5.
Yeah.
3/5. 1 out of 5. If you do odd numbers, there would be half. So it's got to be more than half. Or odd. Did you not read this? Multiple of 5 or an odd number. You got to count the odds also. You with me? Right? So again, if we were looking at the numbers, all right, you're trying to figure out the odds and the multiples of 5. The odds and the multiples of 5. Everybody okay with that? All right, so I'm pretty happy with that. All right. A number chosen at random from 1 to 50. Find the probability of selecting a number with a last digit of 4. What did you get? 110? 4 out of what? What do you think? 110? 110? Good. You don't have to be the same. 110? Okay, so a number is chosen from 1 to 40. Find the probability, from 1 to 50. So that means how many numbers are there? So your denominator should have been 50. Now I want every number with the last digit of 4. All right, so 4 works, right? Then does 14 work? Uh-oh, hold up. 14, then what? 24, 34. Now here's where we run into problems. What? 44, right? Is that it? Right? Is everybody okay? I mean, it has to end in a 4. Can anybody tell me any other numbers that end in a 4? I don't think so. So how many is that? 5 out of 50. I'm not sure what some of you guys are doing. 5 out of 50, which is equal to 1 out of 10. All right. So let's look at number 8 now. A number is chosen at random from 1 to 50. Find the probability of selecting an odd number. That should be kind of easy. 1/2, right? Half the numbers. Does everybody agree? 50 numbers, 25 even, 25 odd. So that was kind of easy. 1/2. A number is chosen at random from 1 to 10. The probability of selecting factors of 4. Factors of 4 and factors of 6. How many? 1/2. 3/10. 2/5. All right, so I got work to do. 1/2. Okay, so that sounded good. So let me see. So I want someone to tell me the factors of 4. What would the factors of 4 be? 1, 2, and 4, right? What are the factors of 6? 1, 2, 3, 6. All right? Now, they have to be a factor of 4 and a factor of what? 6. So let's look at the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is 1 an answer?
Yes.
Is 2?
Yes.
Is 3?
Yes. No.
Thank you. You're right. Very good. Is 3 with both? No.
But in the question, it sounds like it's asking factors of 4 and
and factors of 7. That's what I thought.
I think it said 7.
Find the probability of selecting factors of 4 and factors of 6.
When I read it, it sounded like it was just like both.
Oh, I can kind of see what you're saying.
They worded this.
I can see what you're saying. So some of you want what number is a factor of 4 and a factor of 6, not simultaneously factor of 4 and a factor of 6. All right, so I agree with you on that. All right, I agree with you on that. Find the probability of selecting factors of 4 and factors of 6. Yeah, I can kind of see what y'all are saying. All right, I can definitely see what you're saying. Right, because if you said factors of 4 and factors of 6, then it would just be 1, 2, 3, 4, and 6. Is that what you're saying? 1, 2, 3, 4, and 6. So if you say 5 over 10, all right, I read it as it has to be a probability of selecting factors of 4 and also a factor of 6. Everybody see that? All right, so if you said that way, I wouldn't care either way. And if you said it that way, you would have said 1, 2, and is that it? Yeah, I think that's it. What?
Would that be worded differently on the test?
I'm not worried about it. Yes. But it's what multiplies to make that number. The factors of 4 are 1, 2, and 4. Multiples would be, if I said what are the multiples of 3, you would say 3, 6, 9, 12, 15. Okay? So number 10, a number is chosen at random from 1 to 50. Find the probability of selecting a number greater than 21. So how many numbers are greater than 21? 29 out of what? Yeah, 29 out of 50. All right. Good. All right, listen, I'm pretty happy with that. All right, put your name on it. All right, I'm going to collect it. I want to see if you put some time into it. I got another worksheet for us today. Let's go. Make sure your name's on it.
I like it. Is it okay if I just put your favorite student? Did you know who that is?
Oh, I would definitely know who that is.
What do you need, right?
Here we go, here we go, here we go. Thank you, thank you, thank you.
Oh my god, you look like that person. That.
I thought for a second, I was like, one more different.
I know that yellow page.
Oh, yeah.
That's
Somebody
what
else have work for me. Boy.
My new child.
Yeah, and I.
Thank you, Jessica.
I get so
Okay, now, the next thing on the agenda is where we are doing theoretical probability and experimental probability. All right, so I don't really think that's too difficult. All right. And what do you think the theoretical probability when you flip a coin you get ahead?
Oh, 1/2.
1/2, right? So theoretical probability is just what I know to be true. All right? Let's say you flip a coin and it comes out tails. Listen to me. If it comes out to be tails, all right, it appears. If I said, well, then what's the probability of getting ahead? It seems like it would be what? 0. And it seems like it would be certain, would be 1 would be the other option. All right? Because when you do an experiment, sometimes you can do experiments to calculate the probability. All right? But when you do an experiment, that's why they call it what? Experimental probability. Just like when you roll the dice, the theoretical probability of getting a 1 is what? 1 out of 6. That is correct. All right? But if you do an experiment, your results might be different. All right? If you roll the dice 10 times, 6 may never come up. So it seems as though the experimental probability of rolling a 6 would be 0. All right? That's the difference between experimental and theoretical. So what I want to do now is I want to take a look at the first page right here. And Let me pull it up. Bless you, bless you. All right, let me find it real quick. All right, probability. All right, obviously experimental probability means you're going to do an experiment to try to figure out what the probability actually is. All right, so here we go. Number one, all right, and this is what I was talking about. There's two different kinds. There's theoretical and experimental. So what is the theoretical probability that an even number will be rolled on a number cube? What is it? 1/2. That is the theoretical probability. That is exactly true. Now, what we did here is we did an experiment, and I rolled a cube. All right? And I rolled it frequency. What does frequency mean? What does that mean?
How many times, like, you rolled it?
That's right. How many times a 1 came up? How many times did a 1 come up? 8. How many times did a 2 come up?
3.
Now, I want you to look at this real quick. Does that seem weird that a 1 would come up 8 times and a 2 would come up only 3 times?
Yes.
Yeah, that seems weird. So if you take a short sample, right, the numbers may come up a little skewed. But if I rolled the dice like 10,000 times, right, or 100,000 times, 1/6 of the time it's going to come up what? A 1. Do you agree with me on that? All right, so the more you do it, the more the results become what they should be. All right? But sometimes we don't have enough time to roll the dice a whole bunch of times. So they're saying right here, we threw the dice. All right? And we did an experiment, and a 1 came up 8 times, a 2 came up 3 times, a 3 came up 9, 4 came up 6, 5, 4, and so on. So it says, what is the experimental probability an even number was rolled? What was it?
15.
Does everybody agree with 15? Right? Come on, Aiden. We're going into 7th grade, right? So even. So he's right. Just add those up. So there were what? 15 evens, right? Out of how many times did we throw the dice, though?
36.
So the probability of getting an even theoretical or experimentally was 15 out of 36, then we reduce it by 3, so 5 out of 12. All right, so was it close? Yeah, it was kind of close because it was what? 5 out of 12 and 6 out of 12 is half. All right, so that's the difference. Hopefully you understand what I'm saying now. The difference between theoretical and experimental. So let's do this. If you roll a number cube 36 times, how many times should you expect to roll the number 1? What do you think?
36 times.
How many?
1 out of 36 times.
How many?
6 times.
Yeah, of course, 6 times, right?
6 out of 36.
6. Now, again, listen, if you throw the dice 36 times, here's what we're saying. Normally, it would be how many times do you get a 1 when you roll the dice? 1 out of 6, right? Well, how many times are you rolling the dice?
36.
So it's 1 out of 6. This is the math. Times the number of times that you roll it.
Oh.
That's the theoretical probability. All right? That's the theoretical probability. So that becomes a what? 6. All right? I would expect to roll a 1 6 times if I threw the dice 36 times. All right? Let's read number 4. What?
Why would you multiply times 36?
How many times did you roll the dice?
36. 26. 26 times 36. So, at first, was it 15 other things? Just make the bottom number.
Shh, no one is asking for your help.
Can you explain them again?
I just did. There's a 1 in 6 chance of getting a 1.
Oh, so you're
Times 36 times that you roll the dice. You'll get a 1 about 6 times. That's called the theoretical probability. You with me? All right, we got more. So you'll catch on, I promise.
Okay.
All right. How many times did you actually roll the number in the experiment? 8 times, right? And did we get the total there? Did you guys tell me the total was 36, right? All right, so that's what they're asking. So the experiment says we should have got, or we got it how many times? 8. Does everybody agree with that? Well, I'm not sure. What is the question? You see what I'm saying, right?
Yeah.
Listen, the hardest part, and I'm not trying to be funny here. I'm trying to tell you, trying to be honest. Most kids make mistakes because they don't answer the question. They think in their head they know what the answer is before they even finish the question, and they make careless mistakes on probability. All right. The question says, how many times did you actually roll the number 1 in the experiment? We rolled the number 1 how many times? 8 times. That's the answer. They're not asking for a probability. All right. But the next time it says, what is the theoretical probability of rolling a number greater than 4? Greater than 4 would be either a what? So what's the theoretical probability then? How much? 2 out of 6. Right? I like 2 out of 6. And then, of course, we always reduce it to 1 out of 3. That's the theoretical probability. All right? That's what should happen. What? Well, what's the question? Shh. And again, I'm not trying to be, I'm trying to tell you, the biggest mistake is you just have to understand what the question is asking.
Why wouldn't you multiply it?
Because it didn't say how many times would you expect to roll it if you did it 36 times. The question is simply saying, what's the probability of getting a number greater than 4? Right? And that is? Yes. All right? Number 6. Now it says, what is the experimental probability? What is the experimental probability? This is what?
10 out of 36.
10 out of 36. Now, is he correct?
Yes.
All right, because it's asking for a probability, it's how many did you actually get? 10 out of 36. And if I reduce that, that becomes what? 5 over 18, which is still kind of close. All right, 6 out of 18 would be 1/3. So you're not that far off. Olivia, you okay? All right. Again, I honestly, I just read carefully. All right, you have to read carefully. All right, here we go. It says, what's the difference between the theoretical and experimental probability? Well, what was the theoretical? 1/3. And the experimental? 5/18. All right, now we're back to, do you remember a long time ago when we reviewed fractions? All right, so the correct answer here would be what? 1/18. All right, now if you need me to explain that, I will be happy to. All right, and plus, it's good because we're coming up on ERBs, and you're expected to know how to do what? Add, subtract, multiply, divide fractions. Whenever you add and subtract fractions, you need a common what? Denominator. So you should look at 1/3 and say that's how many 18ths? 6 out of 18, right? Come on, guys. If you forgot how to add fractions, we got a lot of work to do. Right? 6 out of 18. Is everybody good? And then 6 out of 18 minus 5 out of 18 is what? 1 out of 18. Everybody okay with that? What's the matter? Oh, need some help? Okay. All right, here we go. Let's look at this one. It says, if a car factory checks 360 cars and 8 of them have defects, how many will have defects out of 1,260? What are you thinking? I want you to tell me how to do it.
I started 1,260 divided by 360. And I got 3.5. And then I times 8, 7.5, and I got 3.
Yeah, I mean, that's exactly correct. All right, that's exactly correct. I'm pretty happy with that. All right, but again, I want everybody to do this. It's what? 8 out of what? 8 out of 360. Does everybody agree with that? right? So if I reduce that, that gives me a what? 1 out of, thank you, 1 out of 45, right? Does everybody agree with that?
Sorry, I don't really get it.
I'm not sure what you don't get.
So, why do you have to do 145?
I just reduced the fraction. 8 over 360 reduces to 1 over 45.
So, 40. So, 1.
I'm honestly not sure what you're asking me. I have on the board 8 over 360, and I told you that equals 1 out of 45, and you're looking at me like I'm crazy. I'm not saying what the answer is.
Oh.
I just said I reduced the fraction. If you're not sure if I reduced the fraction, you can take 360 divided by 8 and see that that's 45.
Okay.
Right? Yes.
Can't you also do it like a proportion?
Hold up. Listen to me. Guys, I'm going to show you probably like there's so many different ways to do it. There's so many different ways. All right? I'm going to show you what I think you should do. All right? And then, especially because I let you use calculators, it's really a simple problem. All right? But I really want everybody's attention. So look up. All right? So does that, the main thing I want everybody to know is 1 out of 45 are what? Defective. That means when you make 45 cars, what? One of them is going to come out defective, correct? So now that you have your calculators in your hand, somebody tell me what 1 divided by 45 is. What is it?
0.02 repeated.
Okay, so that would be as a decimal 0.02 repeated. Does everybody agree with that? All right. Now, that's also, remember 2 repeated was 2/9, correct? So that is the same as 2 1/9%. Now, the only reason I'm doing that is just because I'm just reviewing with you everything there is to know about numbers. That's all. This is not how to solve the problem. I'm just saying 1 out of 45 is defective. Do you agree? I asked you to divide that on your calculator as 0.02 repeating, correct? I would want everybody in here to be able to say 0.02 repeating is the same as 2 1/9%. All right, I'm not saying that's the answer. What? It's not the answer yet.
Oh, that isn't there.
No, it's not asking for a percentage.
Oh, I know.
It's
But if you turn 0.02 repeating into percent, why?
it should be, that shouldn't be 1/9, it should be what?
2/9.
2/9. Thank you. You're right. Good job, guys. 2/9. 2 repeating is 2/9. 3 repeating is 3/9.
Why is it just 2/9? Because there's no whole number.
2/9 would be
Oh.
0.2 repeating, right? What?
I don't really understand.
So if I said 0.2, what percent is 0.2? 20%, that's all. 0.02 would be what?
3%.
No,
2%.
0.2%. Right, so this is something I'm glad we're reviewing. I want you to listen to me.
Oh, I understand.
Right, 2%, 0.02 is 2%. But this has a 2 repeating. So the repeating is the 2/9, not the 1/9, like I said.
Why is it 28?
28? What are you talking about?
Do you need a percentage?
I'm asking you. You want the answer. I'm not This is the problem I'm having with some of you. All you care about is the answer. I'm reviewing for the ERBs. That's what I'm doing. I'm expecting you to know if I said 8 out of 360, you should be able to reduce that to 1 out of 45. Do you agree with me? You should be able to reduce that or not? If not, our ERB scores may not be what I think they're going to be. You should be able to reduce 8 over 360, correct? You can't? You can't reduce that fraction?
On calculator, yes.
Just divide by 8. What are you talking about? Divide by 8 and divide by, I'm not. Okay, well, just come on. Go. I'm trying to be serious. I got a lot to teach.
So, I'm still kind of confused why it's 2 and 2 ninths, or just the 2 ninths.
Well, because 2/9 would be if it was 0.2 repeated. Do you agree?
Yeah.
All right, that's important to know the difference. All right, everybody good? Now stop. Come on.
How do they want a percentage?
They don't want a percentage.
Just showing us.
I'm showing you. Listen, come on. I'm not trying to be funny. I'm not trying to be mean either. I'm telling you, I'm reviewing. I say you should understand the fractions, the decimals, and the percentages. We haven't done it in a long time. And some of us are struggling a little bit, so I'm reviewing a little bit. All right? Not mentioning names, of course. I would never want to call you out like that, Abigail, but we're going to. What?
I get that you add the 2 to, well, I get that you split 2 to 9, is that because it's not 0.2, but why do you add the 2?
Okay, because, look, good idea. 0.022222. That's what that number is. Do you agree? So all of these 2's repeating are what? Fraction. 2/9. This 2 is for the percent, and this is the 2/9. You good? All right, that's important. And again, not many people know that. I'm just saying we are better. We're good with numbers, so it's been a while since we've talked about that. All right, now let's get back to the question at hand. All right, so now that I've reviewed all this, because I was interested in what Nate did, I hadn't really taught him that way, and he came up with his own method to figure it out.
Did Nathan say, wait,
I don't even, we'll go back and listen to the tape, all right?
can I say that?
No, here we go. Watch this real quick. All right, so this literally means now we can, because I've got it at a 1 out of 45, that means I can just take the total and do what? Divide it by 45. So everybody take 1260 on their calculator, 1260, and divide it by 45. And that should be, guess what? 28. Does everybody agree with that? That should be the answer. I also want you to take, I want everybody to do for me, we could set it up as a proportion, all right, because someone else mentioned that. So if we wanted to set it up as a proportion, because this is what you were thinking of, which is exactly correct, you could have said, what? If 8 out of 360 are defective, then X out of 1,260 are defective, right? And then do cross multiply and divide. So take your calculator out and go 8 times 1,260, and then divide it by 360. And what is that answer? 28. That is correct. All right. Now, the other way we can do is to say, well, 0.02 repeating. So everybody do on their calculator for me. 0.0 and then do 2 all the way across the screen. 0.022222 all the way across the screen. And now multiply that by 1260. And it's still what? That's what I was trying to tell some of you. There are so many different ways to come up with the correct answer. All right? Everybody good with that one? All right. So let's go to the next one. Yes.
Wait, so did you say 0.2 repeating times 1,200?
I said 0.02 because that's 2%. You hear me?
Yeah, okay, I just did that.
All right. Now, number 9. Here we go. Let's see if we can do this. It says, if a car factory checks 320 cars and 12 of them have defects, so what fraction has defects?
So you do 12 over 320.
Yes, so I want to do 12 out of 320.
And then you do
over 560.
X over 560. That's what I'm thinking. All right, now use your calculator. I don't care. So how many would be defective?
It's how many would not.
I know.
Oh, it would. Wait, sorry.
So how many would not be defective? You can calculate the number of defects and then subtract, or you can change your fraction. So you said 12 over 320, so we're just going to go with that.
So 21 would have defects.
That's right. So did anybody else get 21?
Yes.
All right, so 21 would have defects. So then how do I figure out how many would not? Yeah, subtract. And so if I subtract, I would end up with 539 with no defects. Is everybody with me on that? Yes, good for you.
I'm confused on the proportion.
Cross, multiply, and divide.
Oh.
12 times 560 divided by 320. All right, here we go. Number 10. You plant 30 African violet seeds and 9 of them sprout. Use experimental probability to predict how many will sprout if you plant 20. All right, so again, set it up as a proportion. All right, what do we got?
6.
Well, how did you set that up, though?
Oh, I divided, well, wait, 30 minus 10 is 20, and 9 minus 3 is 6. I don't really know.
I have no idea what you're talking about. Tell me, how did you set that up?
Only 1/3 from 30, then you get 20 table 1/3 from 9 to 6.
You guys are good.
What is it?
All right, but that's actually brilliant. All right, but I would prefer we say
I did 9 over 30 equal to x over 20. I did 9 times 20 divided by
yes. There you go, guys. I'm not sure what you guys are thinking about. I appreciate the mental math. That's brilliant, James. Like I said. All right. Does everybody see the proportion is good? Proportion is good. Yes.
So times 9 by 20 and then divided by 30.
Wow. That's cross multiplying and dividing. That's solving a proportion. Thank you, Nate. No, I know. And again, I think that's perfectly okay. But again, it doesn't. You know, that's what I was saying. I'd never really taught what you were doing, but it works. All right, it definitely works. All right, so here we go. Let's look at 11. If you are picking a number between 1 and 20, what is the probability that you will pick a number greater than 14 or less than 4? Greater than 14 or less than 4. What? 9 over 20? I'm not saying she's correct. That's one answer. 9 out of 20.
I don't have. Oh, less than 4? Oh, yeah,
9 out of 20.
9.
Is that good? Because again, normally what I do is I just count them. Greater than 14. 15, 16, 17, 18, 19, 20. And less than 4. 3, 2, 1. I mean, that's just how I do it. Or I just like to count them out. That way, and again, the number's going to be small because I'm teaching you about probability. All right? If we had more time, we'd go into bigger numbers. All right? So let's look at 12. If you are picking a number between 1 and 20, what is the probability that you will pick an even number or a multiple of 3? Even or a multiple of 3. Even or a multiple of 3. What did you get?
Yeah.
I mean, are you just saying that just because you calculated it, or is what you think? Because again, this is what I'm trying to tell you guys. ERBs are super important for us. Or I don't want to. If you haven't calculated like I've been showing you, you're probably wrong. All right, what is it? 4 what? 4/5. 13 out of 20. 13 out of 20. 3/4.
Wait, actually, wait.
Yeah, good. It should be on your page. 13 out of 20. 7/10. 13 out of 20.
about 13.
Yeah, guys. I'm a little confused here. Hey, I'm a little confused by all the different possibilities, all the different answers you're telling me. Most of the time, you just can't look at it and tell me the answer. All right. In my opinion, you should write down the numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, notice again, guys, I'm writing them out because I don't know the answer. I'm not just looking at it saying, oh, that's an obvious answer. It's not obvious. You got to count. All right? So we want to be even, right? We want to be even, right?
Yes.
So right off the bat, we could say, well, I know there's 10, right? So now, let's count. We can just do the evens. All right? So I'm going to count them, or I'm going to mark them, because if I mark them, that means I've already what? I've already counted them. Now the multiples of 3. What are the multiples of 3?
3, 6, 9, 12.
And the problem is, some of them are what? Even. That's why you have to, in your head, that's why you have to count them out. Now the multiples of 3. Here we go. 3.
6, 9, 12, 15, 18.
There you go, guys. That's all it is. Now you just count those. So how many? 3, 9, and 15 are the multiples of 3 that aren't even. So we got 13 out of 20. Those of you guys who got 13 out of 20, thank you for listening.
Oh, I was listening.
All right?
I don't know what I was thinking, but I added 21 and 27 to it.
It's just, that's a common mistake. That's what I'm saying. Honestly, you just have to be careful.
So if there's one that's even and multiple of 3, it just counts as one of the other. Yeah. Okay, so you don't have to count that one.
Right, right. And eventually I told you this. Hey, look up, please. Hey, Ben, I'm trying to get you to listen now for a second. Please, I do appreciate you guys. You're doing great. But listen, I'm trying to tell you the probability here is, watch this, guys. Look up. P stands for probability. Probability of A plus the probability of B minus the probability of A plus B. That's why this is hard. I know. Just listen to what I'm saying. I'm trying to show you how that should be obvious. Please listen. I'm answering your question. I'm answering your question. Listen to me. Advance right here. All right? I'm not expecting you to know that. I'm expecting you to go, oh, okay, that totally makes sense. Probability of A, in this case, would be the probability of getting a what? Even number. Right? This is the probability of getting a what? Multiple of what? 3. This is subtracting out the probability of what? A multiple of 3 that is even. Hear me out. Why are we doing that, by the way?
We already counted these.
Very smart. Very smart. That's why I get on you so much. Just stop and listen. All right? Be brilliant. Don't mess around.
I don't understand.
I had a feeling you were going to tell me that. The probability of A is the first evens. You're trying to get it even. The second probability is you're trying to get multiples of 3. And this is the probability of even and a multiple of 3. So I'm going to show you what. You can think it's 0 if you want. Just listen to me. All right? That's why you're frustrating some of me. You're frustrating. All right? So now, if you use the formula, you will get what? You will get the same answer. So let me show you what that means. What's the probability of getting an even? 10 plus, what's the probability of getting a multiple of 3? 3, 6, 9, 12, 15, 18. How many? 6. Minus the probability of the multiples of 3 that are even. 6, 12, and 18. Minus 3. Yeah, listen. Hey, guys, tomorrow, listen, I think I'm just going to spend time, all right? No homework, all right? We'll finish this. All right, we'll finish.
No.
I know. Listen, honestly, I know you. Some of you guys are listening. I know it's hard too. I'm not kidding. All right.
I am listening.
I know you are.
You